Hi everyone. Today we learn in chapter 10 talk about a booting process in computer and overview operating system. The objective of this class, I think you have experience or some experience to set up the ByUs. When we have a class on site, I will show you how to set up the ByUs and checking the error in the computer hardware. And then you understand the concept of process and thread. The process and thread relate to writing the computer code, and in today we develop the code in the multi-thread. That means you are write a program and split the words to small work like as a thread to do like as the parallel processing. And finally, you will know about the operating system and the words that relate to the operating system. We have only three topics: boot process, master boot records, and operating system overviews. Here, the booting process. Uh, booting. Booting is a process the start on the computer system. When you turns the power on the computers, the first step, the BIOS, this is active by the BIOS checking all the peripherals device. That means all device in your computers. BIOS is abbreviation from the basic input-output system. The BIOS, this is a software. This is a software to check the hardware inside your computer and also make a configuration for each device. After the BIOS check the device completes, it will send the works to the booting. We call the boot device loaders. The boot device loaders will load the operating system to the memory and give all the works to the operating system to organize all of the system. Here, this is a flowchart for booting process. The first step on the left hand side here, when you press the power buttons, it will turn on the BIOS. And then the BIOS make a post, that means checking all of the system. During checking the system, if the BIOS found some error, it will show you like as the beep code. Beep code, this is sound beep beep. And the beep code have a code to tell the user about the some problem in the system. And and you should check the beep code error from the beep code tables, that you can search the beep code from the internet. And then after that, after the complete all of the device is give to do, it will do the master boot record readers. That means if the a partition or a location, a first location on hard drive or solid state drive. And then the first location on the MBR is a point to the location of the operating system on the disk. And then it's load the kernel or operating system to the system. That means load to the memory. Yeah, this is all of the structure during booting process. Now we look at the BIOS. The BIOS evaluation from the basic input-output system. And the BIOS I told you is a first program that's run after you turn the computer on. The BIOS have the intention or the hardware device by makes a self-test and also and call the power on self-test or POS. The main point is the ByUs today have two categories. First, that is a legacy ByUs and UEFI ByUs. I think for new computers or of the new computer today, we use UEFI as mean like as a graphics ByUs and easy to set up all the system. The legacy ByUs this is a obsoleted. This is a very old ByUs style and make a hard code on memory to management, not like as a small operating system and hard code to access the I/O and check the I/O. That means the legacy BIOS show on your screen like this. Here this is the activity 10.1. I show you how to set up the old computer system. If you have a class on site, I will bring the old computer system to show you about the BIOS. Here in this is a legacy BIOS. It look like a TechMOS, and here in this is have a main menu, advanced, security setup, boot device, and exit. And user can config. What is a user can config? User can config the time and date and the device for boot. Here this is a very old and it have a floppy disk drive 1.44 megabyte for floppy disk. And here this is have only 4 hard drive in maximum installing in your computers, and it is show about the memories. And it is another one is legacy BIOS. This is from our software. It have a function setup, standard setup, advanced setup for chipsets, setup for power management. Here in this is a legacy BIOS. In the legacy BIOS for the advanced menu, you can change the speed, CPU speed. That means CPU clocks. You can set the overclock CPU, changing the system bus speed, changing the turn on and turn off some device in the computers. But if you overclock this is over, maybe system collapse or system make unstable for running. For here in this is a UEFI BIOS. It look like a game. It's beautiful. It's showing the graphics and you can change some parameter by the control and organize inside with this BIOS. That means your system not you don't worry about a setting error because you can moving back to the backstage or default setting. Okay, here this is about the BIOS. What is the key on your keyboard that you turn on the BIOS? Some system after you press the power button in a few seconds you press F2, and some system you press F10, F2 or F10. Most of the system press F2, F10. Some system you choose press the escape key first to show the main program, and the main program main BIOS will tell you press F2 or F10 to moving in the BIOS setup. I recommend you not changing anything in the BIOS if your system running stable, because some point you change it maybe change it error and you don't know where you change error. That is the error from making with uh, some point. Example, you change the IO or make the IO speed or make my IO method and you change a lot many location on the BIOS. Maybe you cannot detect which error that's making from the you changings. Here in this is a beep code. When you turn the power on and you have some beep code here. This is a beep code from Dell. The beep code from Dell is if it's if it show one beep, it is a mean BIOS lump corruptions or fails. Or two beep beep is mean about the memory not detected. That is maybe memory have no memory installation or some memory have oxide on the connection pin. And 3 bits mean motherboard fails. 4 bits is about the memory fails or maybe about the oxide in the connection pin. And video card, this is a 6 bit. Most of the bit that user file on the system is about occur from the memory not detected. That is have a problem about oxide on memory pin and also oxide on the VGA or video card pin. That is a occur. That is a show about the 6 bit or more bit. You can check or the error from the bit code like in these tables. And the next one for the type of the BIOS, that is a UEFI BIOS. The UEFI BIOS is an abbreviation from un, Ununified Extensible Firmware Interface. The UEFI BIOS first introduced in 2005 supports the hard disk over 2 terabytes. That means the old BIOS support the hard disk under 2 terabytes, maybe not over 2 gigabytes some system. And supports different CPU architecture from x86 from Intel's and some ARM ARM architecture from AMD. And have here in this main point have diagnosis and repair computer without an operating system installed. That means you can use the BIOS to copy or transfer the data from a new another one drive one hard drive to another hard drive without the operating system by process inside the BIOS. Here in this activity 10.2, if if we have a card on site, I will remove the memory and then your system will show the beep code. And also when we remove the VGA, it is show beep code, not connect keyboard or mouse. Some system not show any file for not connected the keyboard or mouse, but some system show the beep code. Okay, now we talk about the bootloader. The bootloader used for the microcontrollers. Here in this is a microcontroller Arduino's. You already know this is a microcontroller running a program that developed from programmers. The Arduino have a boot code by you program the boot code and program the software with this programmable board like here. And then after your program, you install it into the main board. The bootloader form of the microcontroller. This is when you are plugged to the microcontrollers, and the program will run at the first line here in the first location on memories. The first location is a bootloader. This is a small software to check to configure or setting in the hardware inside the microcontroller. And then after run the bootloader completes, it moves to the application firmware or application software that you developed. The all of the microcontroller today, not only the Arduino, PCI, and a new microcontrollers here in this use about bootloaders. Now the second topic, that is a master boot record. The master boot record is a location at the first sector or a first location on the USB disk or solid state drive that contain a, a pointer for point in another location where is the operating system. Some systems have two, three, one operating system. The master boot record like as a selector to select the which one on the operating system boot or load to the memory. When the master boot record partition or the master boot record location is failed or an error maybe that is a generate your system will not booting or running like here in this. This is a I capture from some system that invalid partition tables. That means the master boot record have some problem for booting. Or here in this non-system disk or disk error. And maybe this is a generate from master boot record from system to tell the user have an error about master boot record or the operating system location. In this picture, we will look at where is the master boot record location on the hard drive. Here, this is a hard drive. Hard drive consists of the ARM or a disk or a disk. And where is the master boot record? The master boot record location here in the red. Here it is. This is the master boot record location on surrender 0, S0, and sector 1. Here in this first location for the hard drive moving to readings. And then the hard master boot record will point to another location for the operating system. Okay. Now we move to the next topics. For the operating system, the operating system is a software for running and install itself into the memories at the first step after boot the process complete. The operating system controls all of the hardware and also over another hardware like as the organizers. The operating system like as an organizer or manager to control the user's resource. Resources mean memory, I/O, internet, or any device in the computers we call resource. The resource controlled by operating system to organize and check the organize it and check the time and sharing the resource to each software. Operating system has a function to protect access the memory location. It's not allow another software to move to another one software that is not allowed it. Allow only a software location that is used in the memory and protect the virus to access into the memory or another location or device or resource in system. 20 years ago, we don't have a high or advanced operating system. All of the programmer in the 20 years ago use DOS, this operating system. This is an interface like as the command line interface, and the DOS have a support for single user or single task operating system. This is a structure of the DOS, the application or any software running over, and then DOS have resident system program, DOS device, DOS device driver, and long ByUs here in this. This is a hardware. All of the application can direct access to the hardware here in this line. Look at this in this line. So you in this line here. That means any application can direct access to the hardware. Or this is a not advantage. This is a problem for DOS. That means some application can access direct to hardware, and some virus can access the hardware if your system infects the virus. I will show you the skin on DOS. Here in this is a skin. In this DOS skin, it look like a command line interface. And here, this is Unix. Unix uh, is in a group of the command line interface. Or here in this is a graphic user interface, UI. I have a new word that is DOS kernel provide IO. What is a kernel? The kernel here. Kernel is mean a program in core of the operating system. That means core program of the OS have functions control everything in the system. In this is a kernel by concept. Kernel connect between kernel to application, and also kernel connect to all the hardware in system. Here in this concept, or here this is a blocks in the Windows system by remove some small module have show only highlight, show only the main module for the inside the operating system. The Windows or operating system today divide the location into part that is a user mode and kernel mode. User mode is mean a location for program, another program installed into system, and kernel mode is a location for the operating system. And when you install the OS have running in the kernel mode in the protect for another application access to the kernel location or kernel mode. So that I conclude the kernel is a program, the core program of the operating system connect between hardware and applications. Now, activity 10.3 make a directory and copy the data from directory A to the include a subdirectory to the directory B by tying the command line, testing on the Windows commands and Mac OS commands. For here, I show you on site or online course. Okay, for the operating system they have three have a forwards. I think you should know forward inside the operating system. That is batch processing, multiprogramming, multitasking, and multithreading. For the batch processing, the word batch processing is come from processing a large volume data. A large volume data, and example, the data in payroll system have a lot of the maybe more than 1 million record or 1 million record processings. And so a range data not processing now is processing spent for uh, hours, more than hours, more than more than uh, more than 3 hours, 4 hours, and sometimes require staff to handle the issue during processing. The example of batch processing a payroll system, bank invoice printing every month, and another the application that is a generate report from the large volume data. For the batch processing operating system, in 1950 to 1965, the computer used the batch processing operating system. Look at the picture here. A user he bring a card reader, that is a paper card, writing a code or data and put it on the card readers. All the data from the card reader read and record to data tape to tape diver. And then a user he bring a tape from the, the, the tape diver to put it into a system. This is a very old computer system. The computer have a input tape, system tape. That means a system program, and record it to the output tape. The program for the 1950 and 1965, the computer have a large system and have a small memory, very small memory. They use this memory for arithmetic logic and not have a memory. Memory that mean memory chip. The memory chip they use the data recorded into the tape. So the system running in the sequential processing, and after processing completes, write the record the output to output tape, and then shipping the data from the output tape, put it into the printing system, in the output report into the paper. Here the process input, processing, and results for the outputs. For here, so the system run very slow or difficult for set the input individually to the system. So all of the program designed to use in the batch processing operating system. During 1965 to 1980, we have new computers that have a high performance. The computer Remaining use the batch processing for range data process, for payload system, or monthly report. And during in this is we have a new word related to the operating system, that is a multi-programming and resource sharing. We will look at which in each word's meaning. For the multi-programming, the multi-programming is a difference from single programming. Single programming, this is a system running only one program running. Multi-programming, that means the system have many program, many software running. So like as a multi-process, like as a multiverse doing. Here in this, look at this feature. We have a three program from three software: program A, program B, and program C. Program B running about I think only 1 second, and then waiting. And here the the next sec the next second, and this is a program B loading 1 second, and then program B running here in this. In the program multi-programming have a function switch. Switch is means switch from program B from program A to run in program B, and then switch to program C. This is a switch from each program running. During switch, this is a remove some program from the CPU, from the cache memory inside the CPU, and load a new program to the system running. So here this is when switch very fast, when switch very fast. Very fast is mean or under 1 second, maybe switch in 0.1 second. The users feel running system in a single processor, single core. This is a feel like as a uh, multi-program running at the same time, but it is a have a switching, but switch in very fast. So now I conclude multi-programming is mean a many program running in a system by use switching selection to switch the process on the run onto the CPU. And the next was this is related to the resource sharing. Resource sharing. This is a very not difficult for 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 concept here. In this is a feature. We have three job 1, job 2, and job 3. And this is a wish out resource sharing. The job 1, I suppose this is a program A. Program A. The job 1 hold only a CPU about maybe 60%, 50%, and hold the memory, use a memory only 10%. Yeah. And job 2 or program 2, program B, hold the CPU 10%, memory, I think 1, 2, 3, 30%, and use terminals. Terminals is a display 20%. And job 3, program C, hold the CPU, use the CPU 10%, memory 20, disk 100, and printers 100. So here processing by switching program A, program B, and program C by sequence. The program A spends 5, 5 minutes 5 minutes for processing, and then program B processing 15 minutes, and program C processing 10 minutes. So the system which our multi-resource and multi-programming, the system spend the time totally 30 minutes. But the system have an operating system, have a function, resource sharing and multi-programming. This is will combine all of the works to do at the same time. Here in this, total CPU running 90% by here 60 uh 6 10 maybe it is a 20%. And memory is whole 20, 30, and 10 is totally 60%. And here for this 100%, terminal 20%, and printers 100%. Totally is can running all of the work, job 1, 2, 3, or program A, B, C, spending the maximum time processing only 15 minutes. 15 minutes. This is the concept of resource sharing and multi-programming. Now, from the new computer start from the 1980 to present, it have two new words, that is multitasking and multi-threading. But computer today remaining batch processing, multi-programming, and resource sharing, but it have only two new words. Now I explain the difference multitasking and multi-thread. Task is mean job. Multitasking is CPU running with various jobs. Various job multitask at the same time. In a job, have a small job. In a job, we have a small job. So the small job like as a thread. So that thread is a smallest execution unit within running program. And when the program load into the memory, we call process. When the program loading into memory, example, I open Microsoft Word. Microsoft Word load into the memory, we call process. And also Microsoft Word have a process ID. Process ID for process ID, the operating system use a process ID to point a location which application by detect from the ID. Software after loading to the memory or CPU called process. And here indeed this is the main point. A process has one or more threads. I explain in this picture here. I suppose I open Microsoft Word, and after Microsoft Word load into the memory, it's called process, and this is a process. Inside the process, have treated by this is a thread one. Thread one doing about the automatic save data, and here thread two. This is gamma checking, and thread 3, this is uh, y- uh, cursor control. Cursor control. So here in this, the program has a multi-thread. When your system have a multi-core CPU, example, your system have 4 core, in each thread can run in each core, but not conflicts the works when it have a conflicts the works, maybe run only a single core. So here this is a conclude about the multitasking and multi-thread. Now finally for this chapter I show you the screen capture from each operating system from the past to today. Here in this I think this is a DOS and this is a Unix, and also here in this Unix, and in this is it look like Windows. Yes, Windows Windows version 3, and this is a OS 2 from IBM, and here this is a Max, and in this is the Windows Me, Windows. I think this is a Windows XP. Here in this Windows 95, and here in this Windows NT for network. All of this is obsolete. Windows 2000, Red Hat, Red Hat in the Unicorn, and Max. Here in this is for current system. Windows 7, Windows Win I think Windows 10, maybe Windows Server. Here in this is for in this chapter. Now we will conclude for this chapter. I think you understand the booting process, master boot record, and some words inside the operating system. Thank you for watching in these chapters. Bye bye.